Alright guys, in this video we're going to be talking about electrolytes and eventually the different types of electrolytes. So basically electrolytes are going to be a bunch of ions in the water that are responsible to conduct electricity in the water. If you don't have any ions in the water would not conduct any electricity. So the electrolytes are categorized into three different types. You can have a strong electrolyte, a weak electrolyte, and a non-electrolytes. So the definition, starting out with strong electrolytes, is going to be the one that ionizes completely. So what that really means, if I have a compound, let's say AB, so AB, when I dissolve that in water, what it's going to do, it's going to completely ionize into the ion. So it could very well make A plus aqueous and B minus aqueous. So one way to identify a given equation if it belongs to a strong electrolyte by looking at how it's written out. So if you have the starting material, which in this case is AB, and if you have the reaction arrow just going one way and it's making the ions, so that means it has been broken into the ions completely. So let me take a real life example. So suppose you have NaCl. So when you add NaCl in the water, what happens? It dissolves. Okay, and the reason why it dissolves, it breaks into the ions. So it's going to break into Na plus aqueous and Cl minus aqueous. Okay, so it's a strong electrolyte because it completely ionizes into the ions when you put that in the water. So other example I can probably talk about is HCl, which is a strong acid. So HCl, when added to in the water, it breaks into H plus aqueous and Cl minus aqueous. Okay, so if I want to overall give an examples of strong electrolytes, any strong acid you see and a strong base you're going to see, they're going to be the strong electrolytes. Okay, so remember your strong acid's going to be HCl, HBr, HI, and then some other strong acids are HNO3, and then you got H2SO4 and HClO4. So those are the 6 strong acids, inorganic acids, that you have to really worry about. And then as far as the bases go, your strong base is going to be the alkali metal hydroxides. For example, lithium hydroxide. I can talk about sodium hydroxide, and then any alkali metal you have along this line. So all the way, talk about potassium hydroxide, rubidium hydroxide, cesium hydroxide, all the way to francium hydroxide. So those are going to be your strong bases. And some other strong bases are going to be like a barium hydroxide. So as long as they break into ions completely, that's going to be a strong electrolyte. Now, in addition to the strong acids and strong bases being the strong electrolytes, your salts that are actually soluble in water, so I would say soluble salts, are also going to be your strong electrolytes. So let me just erase that real quick. Okay, so in order to figure out which particular salt is going to be soluble, you have to look at the solubility rules. And I'll just take an example of NaCl. NaCl is salt, and it breaks into ions. And I can probably take an example of, suppose I got FeCl2. So FeCl2 also dissolves in water, and it's going to break into ions. It's going to make Fe2 plus aqueous and 2Cl minus aqueous. So if you're adding the same amount of moles for a given salt, whoever breaks into the more ions is going to be a better electrolyte. If you're trying to compare, suppose, between the NaCl and FeCl2 here, and if you're adding the same moles of NaCl and FeCl2, FeCl2 breaks into more ions. It breaks into one Fe2 plus and 2 chlorides. So since it breaks into more ions, it's going to be a better electrolyte among the strong electrolytes. But the questions more or less is just going to be able to identify your strong electrolytes, weak electrolytes, and the non-electrolytes. Okay, so let's talk about what weak electrolytes going to be. So your weak electrolytes, they ionizes partially. And a good examples for weak electrolytes going to be the weak acids and bases. Now there's tons of different examples of weak acids and weak bases, so I'm not going to write those down here. But how do you really write a weak electrolyte? So suppose I have this AB aqueous when it's dissolved in water. Now when it dissolves in water, it breaks partially into ions. So you will have an arrow going both ways. So that's going to be the difference between writing the reactions of the strong electrolytes and weak electrolytes. So you see the ions being formed in there, but not all the way. So that's why you have this reaction sign that goes both ways. So if I want to go ahead and write an example, suppose I got HF. So HF, when placed into the water, it goes both ways in terms of ionizes, or another way of saying it will partially ionizes to H plus and F minus. And some salts also do that, so it really depends on the solubility of the salts. I can talk about maybe NH3. So if I add NH3 in the water, so that's one of the ways how to write the reaction of NH3 with the water, it's gonna partially ionizes. So it's going to grab the hydrogen from the water, makes NH4 plus, so it's making an ion. So it doesn't really matter what kind of ion you make as long as it's making the ion and an OH minus. All right. So like I said, good examples for the weak electrolytes going to be something that ionizes partially, and that's going to be the weak acid, weak bases, and you also have some salts. So it's not that easy to figure out just by looking at it and see, okay, if that's going to be a weak electrolyte or not. When it comes to strong electrolytes, relatively simple because you can focus on the solubility rules, and whichever dissolves completely, it's going to be a strong electrolyte. And if you have a salt that dissolves partially or breaks into ions partially, it's going to result into a weak electrolyte in an overall solution. Okay, well, let's talk about non-electrolytes. So non-electrolytes, they do not ionize at all. They may dissolve in water, but they're not going to ionize at all. So let me take a really good example. So when we add sugars, so sugar is C6H12O6. So if I have a solid, obviously the sugar is going to be solid in the beginning. When I add that in water, it's going to actually dissolve, and it's going to make an aqueous solution. Okay, now it dissolves because it's polar, but it really does not break into ions. So it just still stays as the sugar molecule. So you can see the difference in writing the equation for the non-electrolytes, where you can see, okay, we got this sugar making the aqueous solution and having an arrow that looks very similar to what you have seen in case of strong electrolytes. But the difference is, in strong electrolytes you have these ions produced, but in non-electrolytes you don't have these ions produced. Okay, so that's why it's going to be non-electrolyte. It's not going to ionize, and it's going to be considered as a non-electrolytes. So what are some examples going to be of non-electrolytes? Well, sugar, a lot of sugar molecules. You can talk about glucose or sucrose. They all dissolve in water. So talk about glucose, sucrose, and you can also have some covalent compounds that are polar. So we can talk about polar covalent compounds. And I can probably talk about alcohols like C2H5OH. I can talk about CH3OH, a lot of alcohols, they dissolve in the water, they mix in water, but they really don't ionize in water. You can talk about consuming alcohol. When you mix consuming alcohol and water, they do make a miscible solution, but alcohol doesn't really break into ions in that case. It just dissolves in water. Okay, so then you can talk about some other covalent compound that are just fairly polar to be able to dissolve in water. All right, so in addition to that, the other important character a strong electrolyte and weak electrolyte and a non-electrolyte will give you is how fast or how much electricity they can conduct. So a strong electrolyte is going to be very strong conductors of electricity. The weak electrolyte is going to be weak conductors, and non-electrolytes do not conduct electricity because they do not have any ions in there. Um, Now, if you if you're trying to test out by using an electric bulb or a light bulb, if you dip a light bulb in a strong electrolyte solution, it's gonna have a fairly bright light. All right. If you dip it in a weak electrolyte, it's gonna have a dim light, or it may not even turn on, depending on how many ions you have in that given weak electrolyte solution. But if you have enough ions, you may see a dimmer light. And sometimes you can focus on the electrodes and you see a small movement around the electrodes, and that tells you that, okay, it's going to be a weak electrolyte if it doesn't light up. Now, for the non-electrolytes, it's never going to light up the electric bulb because you don't really have any ions. So you have to have an ion motion in order for the electricity to kind of pass from one position to another position, or you can say one electrode to another electrode. All right, so this is how you guys going to be um, doing the difference between different electrolytes and what their characters are in terms of lighting up a light bulb. All right, if you have any questions, feel free to leave any comments in the section below.